Looking at the slide in front of you, you can see we have an example here, a question, and the question says, how does output y change when inputs k and l are doubled? Seems like a good question. How can we go about approaching this? Well, we want k being some positive number. Why don't we double it by multiplying it by 2? And we'll take labor L and we'll double it by multiplying L by 2. And so I will rewrite, I'll rewrite our function with the inputs doubled. So we have A times 2k raised to the power of 1/3 multiplied by 2 times L and in brackets and raised to the power of 2/3. Next, we want to use our rules of exponents that says that we can rewrite this as a times 2 to the power of 1/3 times k to the power of 1/3 multiplied by 2 to the power of 2/3 multiplied by L to the power of 2/3. Again, we can use the exponent rule that says if they have the same base and they're multiplied with each other, we add up the exponents. So we've got A times 2 to the power of 1/3 plus 2/3 times k to the power of 1/3 times L to the power of 2/3. And we end up with 2 to the power of 2 times A k 1/3 L 2/3, which is equal to y output, right? Y over there. And we can see that if we double our inputs, what happens to output? Output is going to be doubled as well. And we call this constant returns to scale. If we're increasing capital and labor in proportion, we will increase output in the same proportion. Don't confuse this concept with diminishing marginal returns. Right? The marginal product of capital said that there was diminishing marginal returns to capital. That's why capital was in the denominator before. But this is about returns to scale. Right? If we increase both capital and labor, then and by the same proportion, we can increase output at the same proportion as well. Here's a more formal way of looking at returns to scale. Suppose we have a general form Cobb-Douglas function where x is being raised to the power of a and y is raised to the power of b. Suppose we multiply both inputs by the same number t being some number, real number greater than 0. So it could be 1/2, it could be 2, it could be any positive real number. If we do that, we're going to get f xy is equal to a txa t times y raised to the power of b. And since I showed you the algebra just a moment ago, we can make this a little bit more, do this part a little more quickly. I get this result, and the result says that the exponent on this t constant is going to be a plus b. And we can interpret what kind of returns to scale we have by analyzing the exponent a plus b. Now, as in our previous example, if a plus b is equal to 1 and we double all inputs, we're going to double output. And we define that as constant returns to scale. So if we increase labor and capital by 1%, both of them by 1%, we expect output to go up by 1% as well. But what happens if a plus b is not equal to 1? If a plus b is less than 1, then we have something called decreasing returns to scale. And if we increase our inputs by 1%, we're going to increase output by less than 1%. Similarly, if a plus b is greater than 1, we double all the inputs, we're going to get more than double the outputs.